1 second, okay. Okay, recording started, so we are done with this. So first information, when and where you find the recordings of the lecture. Everything is recorded. Of course, the online lectures first, but also the lectures that I'm delivering on Monday, they are recorded. You will find them within usually from 24, 48 hours after the lecture. You will find them in Virtuale and on YouTube. So let's start with Virtuale. Anyway, it is a bit slow. So let's go back to my website. So videos are available here. Video recordings of the lecture will be made available on YouTube and Virtuale soon after the lectures. Okay. YouTube, you click here and okay, let's accept. Let's accept. And you see an empty list, of course, because I'm not, how to say, I cannot see the future. Anyway, but from tomorrow you will find here the first recording of today, okay? YouTube, first of all, again, I like YouTube because it's open. The lectures that are, the links from Virtuale are not open. And the fact that I'm putting lecture on YouTube requires that everything is open access, otherwise I get banned. So just take into account that everything indeed is open access. And what I don't like of YouTube is advertisements. Be patient. I'm not monetizing at all, but you know that from a couple of years ago, YouTube started, even for people who do not monetize from views, started to put advertisements. It's something that I don't like. On the other hand, you know, on the other hand, I still think is the most efficient way of sharing. If you have any better suggestion of something that is as efficient, open, and without advertisements, let me know. Okay. Okay. So this is the link on YouTube, and in Virtuale you will find the lectures under on the right under Panopto. What I put in Virtuale is the same file that I put on YouTube. Okay, so I'm not using the full options of Panopto. You may know that Panopto gives more opportunities, like to use 2 cameras, etc. So I'm not using these opportunities because I want also to be open, and so I'm just taking video from one source. So what you see on Virtuale is the same that you see on YouTube. Good. Now let's go back to my website. Okay. First, we have part of the hours delivered in online only, and not really. I think is 30%, not really half. It's 30%. So this means that on Thursday, until we have lectures on Thursday, which I think, good morning, which I think is until the end of April, something like that. I will show you the calendar. On Thursday, we will go only online. Okay, this is part of an experimental setting that the university started a couple of years ago after the pandemics, when we came back in physical presence. They decided for a limited number of courses, decided to allow teachers to apply for delivering online lectures. I applied, and actually a few teachers only applied. I applied because during my experience, during the pandemics, I was not really dissatisfied by online teaching. I recognize that exams must be taken in presence, because online is really not a good experience for the teacher for sure, but I think also for the students, unless you are so smart to be able to cheat in a smart way. And I have a son who is attending the high school, and I was really amazed how they could cheat in a very intelligent way. But otherwise, it's I mean, you smile, but I tell you, I was really, I think they outperformed the students at the university. At the high school, at least in the class of my son, they outperformed. I was really impressed. I couldn't do something like that. Okay, but anyway, I don't think it is a good experience. So I thought that exams need to be taken in physical presence. By the way, please don't ask me to take the exam online. It's not possible. It's not allowed. I cannot. Okay, and I could obtain permission for some exceptions, but one by one, and I have to apply to the university. It's a long process. Just a few exceptions I could make for Erasmus students. I give you this information because it happened that, you know, if you are in Erasmus, at a certain point you go back, and indeed to travel back to Bologna for only taking the exam may be a problem. But the university is not very keen on giving these exceptions. So Erasmus students, please just take into account, plan in advance, and let me know well in advance if you have the feeling that you may be in the condition to ask for such kind of exception, okay? And try to avoid it, because it is a very lengthy process and it is really frustrating. So try to avoid it, but if you really have the need for major forces or a force majeure, I don't know how to say in English, in Latin, and if you have this need, just let me know in advance, okay? And as I said, I thought that the exam need to be in physical presence, but on the other hand, I thought that the lectures could be a mixed solution, maybe the best thing. Of course, we need some physical interaction because it's much better, because you know, there are some clarifications, some feelings, because feelings are also part of teaching that you can only deliver in physical presence. At least for me, what I can tell you is that when I am in physical presence, I can really realize if I'm teaching well in an interesting way, if I succeed in getting your attention, which I think is a target for the teacher. I need to succeed in getting your attention. So if I see that you are, okay, if it's one person that is sleeping, it's not a problem. But if I see that half of the classroom is doing something else, it means that I have a problem. I have a problem. I mean, it's not your problem, it's my problem. And therefore, you know, online, it's much more difficult. Of course, you may do that with the cameras, but on the other hand, it's really. But on the other hand, I think that these subjects can be efficiently delivered online. I also checked with the students. This is, I think, the third year, which I'm teaching in hybrid mode. And I checked with the students, and also the students looked happy of that. I will check also with you, okay? Because of course I could also disapply for this solution and teach in physical presence. It doesn't change much for me. But I think that some part of the course, if you have the opportunity to just sit in front of your PC, is better than attending in physical presence. So this is the reason why. It's not a matter of personal convenience. I tell you, for me, it doesn't make a real difference. But I will be interested in getting your opinion on that. So what is the calendar of the lectures? The calendar is here somewhere, okay? You see that I already removed Feb 22nd, and you see that the online part of it ends end of April. And it is end of April, I mean, it is May 2nd because I moved 2 hours from Feb 22nd to May 2nd. Otherwise, it would have been April 22nd or something like that. There are some breaks here. I think, apart from the Easter break, I think there is a break mid of April, April 11, April 22nd. Yeah, April 22nd I can teach. And it's not a long break, actually. It is, there are some Thursdays that are skipped, because I have some commitments and I prefer to teach most of the lectures myself. Okay, this is the calendar. It may change, of course, for many reasons. It should also already take into account the pauses, the breaks for degree days and the breaks for holidays. I don't think we have many holidays. There is April 25, but I don't think it is affecting us. And otherwise, everything is already included. One thing, you have also a calendar in the website of the university. So please, it is not updated. So follow this calendar on my website, okay? For instance, in the website of the university, there is still scheduled the lecture on Thursday because it takes some time to change it. So just follow this one, okay? This is the true one. I will try to, and also in the official calendar, you will see lectures after May 20, up to June 6 or 7, something like that. So it is not updated. If we don't skip any of these lectures on May 20, we are done, okay? May 20, I put 4 hours because I'm taking 1 hour more for a visit in the lab. I will make sure that there is no clash with the subsequent lecture. I think the subsequent lectures may also be finished by that time, but I will make a check, okay? And if we cannot make 1 hour more, we will recover 1 hour in May 27. But my plan is to finish by May 20, okay? And also, maybe that one of these lectures is substituted by a field trip, but I cannot really be sure on that. I need to apply to the university to see if we can get the money. If not, I can find other ways of getting a field trip. Anyway, I will keep you informed, and everything, any change will be recorded here soon. But once again, don't look, please, at the official schedule in the university website. Okay, perfect. One more information. This course has two titles, Climate Change Adaptation, Floods and Water Resources in a Changing Climate, because it is a course for students in engineering and for students in physics. There is a degree program in physics. Can you please close the door if you are done with the, okay? Thank you very much, because otherwise in a minute they will make the first break and there is a lot of noise. I understand that it's, you know, it's a small room for so many people, so I will open the windows during the break, okay? And as I said, it is a course for the degree program in engineering and physics. So I think there are 2 or 3 students from the degree program in physics, which is also a program on climate change. So the title is different, but actually the content is the same. And this is not, a problem. It's not a problem because actually this course, the part in climate change adaptation, has a special focus on water resources. And there is a reason for that, because the impact of climate change on society is mainly articulated through, or mainly, let's say, vehiculated, transmitted through water. I'm sorry, I'm not using the correct English word. Sometimes I need to think about the correct terms, and I realize that sometimes I don't use the correct terms. So if you are an English native speaker, just feel free to correct my wording here, because, but I will tell you. So as I said, the impact goes mainly through water, and this is why I will explain also you why. There are other impacts that have nothing to do with the water cycle. Like, for instance, wildfires or hot waves. They are not directly correlated with the water cycle. Indirectly, yes. I would say that indirectly, every impact of climate change goes through the water cycle. And why I say indirectly? Because, of course, hot waves the impact of hot waves is larger if you have water scarcity for obvious reasons, and also the impact of fires, of course, in terms of if you have a scarcity of water, the hazard is, the vulnerability, let's say, is higher. And so this is why this course on climate change adaptation focuses in particular on the water impacts. And among the water impacts, floods are playing a relevant role. This is a relevant impact of climate change. And when we talk about climate change adaptation, we also mean, for a significant part, in adaptation to flood risk and water resources as well. So this is the reason why there are different titles, but the content is very compatible, okay? And of course, for the students in physics, the exam will be a little bit different, as I told you. Okay, so what is our focus? Our focus is climate change adaptation, including floods and water resources, including adaptation to floods and adaptation of water resources management. Why climate change adaptation? First of all, because of climate change. And you know that climate change is a relevant issue. It's extremely important, has a significant, a large impact on society, on humans and human society. And in order to fight against climate change, we have two main solutions, two main categories of solutions. They are called mitigation and adaptation. We will discuss them in detail. But I want to anticipate the concept. Mitigation means that we remove climate change. We take actions in order to mitigate climate change. I said remove in a provocative way, but to mitigate climate change. It means that, for instance, global warming is mitigated. So the increasing temperature in global temperature is mitigated. Okay? And the main action to obtain the mitigation is the reduction of CO2 emissions. Okay, we will get into the details. Not much about mitigation, because we are focused on the second category of solutions, which is adaptation. What is adaptation? Adaptation means that we accept climate change and adapt to it in order to mitigate the impact. Okay? And beware of the difference between these two categories, because it's extremely important. It makes a big difference whether we decide to mitigate climate change or whether we decide to accept it and adapt to it. Why big differences? For instance, in terms of economic resources, the solutions are different. If I want to mitigate, the actions are different. If I want to adapt, the actions are different. And we don't have resources for everything. So the ideal situation would be both of them. I mitigate climate change, and while I wait for the effects of mitigation, I adapt to it. But we don't have enough resources. The first thing that you have to learn is that any action against climate change has a societal cost, and the cost is to be paid by the citizens. And if we charge costs to the population, to people, the impact of this may be very massive, especially for the people who have less access to resources. You know that another issue of climate related to climate change, but another issue in general today is increased diversity, equality, and inclusivity. So if you just charge the costs on people without making any difference, the most suffering categories of people are those living in countries with a low GDP, gross domestic products. So we don't have resources for everything, because, acting against climate change, again, requires a cost to society. It's not just a matter of political will. There is also the problem of the political will, because some actions are not popular. So politicians are a bit afraid to lose consensus. This is also a problem. But there is another problem, which in my opinion is more relevant. Even if the politics wants to, we don't have enough resources. And if we try to push these actions forward, we generate an impact to society which is more relevant in the countries that have a low GDP, gross domestic product, less resources. So this is why solutions are different. We cannot apply both of them. And just to name another difference, it's in terms of time scale and in terms of spatial scale. Mitigation takes time, adaptation takes less. Okay, if I build a dam in order to store more water, I mean, in 15 years, I can build a dam. Climate change mitigation takes a long time. We are not clear what is the time scale, but it's long. And the spatial scale, mitigation is a global action. Adaptation is a local action. Keep in mind these differences. We will discuss again about them because the spatial scale is essential. In terms of responsibility, mitigation is a global responsibility. You need agreements between countries. Adaptation is a local responsibility. It's just a matter of the local administration. And this is why local administrations sometimes prefer mitigation, because they waive their responsibility. There is another difference, which is disciplinary. And it is important for students like you to understand the disciplinary difference. Mitigation is a matter that pertains to atmospheric sciences, climate science. Adaptation pertains to engineering. And this is something that, I mean, you may say that I am biased because this is a concept that is not universally accepted, that adaptation is a matter of engineering, but actually, it is mainly. Of course, there are some adaptation strategies that don't require engineering design, but I would say 95% of, you can take this chair if you want. Yeah, you can take it. 95% of adaptation actions need an engineering design. And this is a big difference because if you need a design, an engineering design, it means that only licensed people can do that. And it's a big difference in terms of licensed. I mean, for those of you who are Italians, ingegneri iscritti all'albo, okay? Because in almost any country, you need to get a license. After you get a degree in engineering, in order to sign a design, a project, you need to get a license. And if you don't have this license, you are not allowed to. So, I mean, it is an extremely important difference. And keep in mind, when you sign a project, you take responsibility for it. So if something goes wrong, you can be charged. You go in front of the court and you have to justify why you made this decision. So this is a big difference between engineers. It's a difference in background, but there is also a legal difference between engineers and scientists of any discipline, like climate scientists. You may have heard, if you are an Italian student, but even if it has been discussed at the global level, about the sentence of the Italian court against the scientists who provide consulting for the earthquake that occurred in L'Aquila in 2009, I think, and they were charged for having made a wrong prediction. Actually, it is much more complicated of that, but you may have heard that they were charged and they were condemned to prison. Actually, they didn't go to prison because they got conditional, I don't know how to say in English, but conditional release, conditional liberty. We say libertà condizionata in Italian. And but they were, I mean, condemned. So this is indeed something that triggered a very large debate, like scientists are responsible for what they do, for their investigation, for their researches. And this was considered to be a big issue, a big question mark. Actually, for an engineer, we are used to be responsible for what we design. So we didn't understand actually the visibility that was given to this question mark, this question. Scientists are responsible if they made mistake. But medical doctors are responsible, engineers are responsible, so why not? I mean, if we are scientists and we make a mistake, I think we should bear the responsibility for that. But this is a discussion that goes beyond our course. But beware that I like also to deliver to you information that is not really pertinent to the course, but I believe it's interesting for the course. Okay, so climate change mitigation and adaptation. We focus on adaptation, and beware that there is also a huge debate at the international level, because given that resources are limited, some people are convinced that we should give up with adaptation and give all the resources to mitigation. Other people think the opposite. And it depends on where you live, and it depends on your experience with climate change. There are some people that are not very impacted by climate change, so they feel like, it's an issue that is not so relevant. Other people are more directly impacted, so they are more sensitive to that. Okay, so we focus on this. We focus on actions for adapting to climate change. We will talk about mitigation, but just briefly. And in terms of these actions, keep in mind that we are not focusing here on politics and economics. Economics a little bit, but very, very little. We are focused on the science of it, on the science in terms of, because also politics is a science, but science in terms of hydrology, atmospheric sciences, climate science. Okay, hydrology is the science which studies the water cycle. Hydrology should be a part of climate science because climate is driven by the water cycle, but they are traditionally considered two separate disciplines, climate science and hydrology. And also in conferences, they are discussed in meetings separately. And so we are focusing on the climate science, the hydrology, and the atmospheric part of the engineering part of these actions for climate change. We don't talk about adaptation through political actions or economic actions. And we don't talk about them because this requires a different approach and more time. So if I had more time, I could speak a little bit of economics. Politics, I'm not so experienced. Economics, a little bit. But we will not discuss of them. And please beware, we are not focusing on climate change attribution. This is a different story. So what is the reason for climate change? Because you may know that a large part of the scientific community is convinced that humans are responsible for climate change through CO2 emissions. There is a small part of the community that is convinced that there is at least a part of natural variability. The question is not really completely clear because, I mean, if you say it's just natural, only a few scientists are convinced of them. If you say that a part of climate change is caused by natural variability, then the number of scientists increases because most scientists are convinced that there is a combination of things. But we are not focusing on this because this is a quite controversial debate with political and economical implications. And I don't think it could be the focus of this course. So I just want to make it clear because I know that it is a relevant issue to determine to what extent humans are responsible for it. I know it's a relevant issue. I know that it's not settled. It's absolutely not settled. So it is significant also from a scientific point of view. On the other hand, I prefer to avoid this because I think it would require a complete course on it to study the literature, the relevant literature. It's not really easy. You cannot look only at the media. You need to go to the scientific literature, and it's a literature that is not easy. Also, with implication in statistics, it's really not easy. It's much easier to focus on adaptation. So I just wanted to make this clear. Okay, now let me just go again into the details, okay? So I opened a parenthesis, an interesting parenthesis of what we will discuss together. Now let me go into more practical details again. So I already talked about the calendar. And now let's talk about the exam Okay. The documents, let me wait a little bit. Exam, videos, already calendar, I did it. Exam. Okay. So, the exam, first of all, is through a quiz plus a short oral examination. Okay. And why a quiz? Because I talked with the students when I started, and it looks like the students are happy with the solution. Keep in mind, you are individuals, you are very diverse. I hope you are diverse. So there are for sure some students among you that like the quiz because they are afraid by the oral examination. There are for sure some students who are afraid by the quiz and they would prefer an oral examination, full oral, okay? Yeah, of course, this is perfect, and it's the reason why I decided to take an hybrid, again, solution, so a quiz plus a short oral. There is an advantage with this solution, which is the rapidity, and especially for you. For me, it's not a big issue. I can make exam for 1 day or 3 days. It's not really a problem for me. But for you, of course, I understand. Usually, you have a limited schedule for taking exams, and if an exam lasts for 3 days, it's a problem. Of course, even if you knew that you are in the third day, but you know it at the last minute. So while it's more convenient for you to know already, if not now, in 1 week from now, to know what is the date of your exam, and it's more convenient. So this is for sure an advantage. Another advantage is that, if you make a mix, of course, I am in a way, I have a higher probability of getting your best skills through the best way, because you can select whatever is you can, I mean, if you are afraid by the oral, you can make your best in the quiz and vice versa. Now, how it is done, the quiz, it's written there, 30 questions, and with close answer and no penalty for wrong answers, with a duration of 30 minutes. To give you an idea, the best students usually after 15 minutes are done. 30 minutes are really a good time. You don't have to be afraid by the duration of 30 minutes. When you take the quiz, I will give you also some suggestions to optimize your time. And the system gives to you opportunities to optimize your time, because you can navigate between questions, you can change your replies. Navigate, it means that you have a navigation panel, you can go to the first, to the last, and you can flag questions because maybe that you answered, but you are not sure. So you can put a flag. So you have option also to revise your replies. I will give you suggestions like reply first to the question that take a few seconds, because some questions take 5 seconds. Other questions may take 2 minutes. So the best solution is that you go through questions and you first reply to those questions which look easier, and then you may take like 15 minutes to think on the 3 remaining questions, 3, 5. And you can consult your notes. I'm not, how to say in English, I don't know, but I'm not so strict. So you are allowed to consult notes. My notes are on the web, so you are allowed to open another web browser and look at that. I really discourage you to do that because it takes time. So it's much better to spend a little bit more time during your studies. And it's much better for the sake of your mark, not to speak about your personal CV, your personal education, your personal skills. So I really discourage you to do that, only in case of emergency. Like, okay, you have 10 minutes, you have one question that really you have some doubts, okay, go on the web and spend 5 minutes to look at my tutorials because you don't remember what is the lecture. Okay, the lecture is this one, and then where is the reply? Okay, everything that you need to answer to the quiz is in the tutorial documents that I will discuss with you now. So questions are taken from there. So just keep this in mind. So you don't have any surprise. okay? You don't have any surprise. And so even if you don't take notes during the lectures, you just look at my notes, that's fine. Of course, I'm talking of the quiz and the exam. Another thing is your personal skills, okay? I will talk, also discuss about these, okay? And the quiz for non-engineering students is different, okay? And if I don't forget, I will tell you, like this topic, please beware, non-engineering student, this topic is interesting for you, but will not be asked at your exam, okay? I'll tell you, okay? Still, I think I suggest you not to forget about these things, okay, for your personal skills and background. Now, the oral. First thing that I would like to do, last year, at the oral, in the first exam, I gave the opportunity to the students who answered to all the questions of the quiz correctly, not to take the oral. This is not going to happen forever, okay? Because I tell this because I had some discussion with students who said, I want to get the same opportunity. It's different because it depends. The quizzes are different from one student to another. So I also look at casualty, how casualty made the quiz, okay? And I also look at, at the kind of answers. So any situation is different. And also I look at the behavior of the class. So if I look at the class really, because I realize it, I really look at the notes, whatever, then I think it's safer for me also to take the oral, because I want to make sure that if I give the max mark, if I give a 30 or I give aloud, it's given to a person who deserves it, okay? It's because I think it's for your own personal advantage. I mean, you have to be reassured that if you get 30, you deserve 30. Otherwise, it's not good. I mean, it's not good for you. For me, it would be easier. 30 to everybody, okay? 5 minutes, I close the exam, and it's fine. But for you, I think it is more rewarding if I am a little bit. So sometimes I give the opportunity, if you make a very good quiz, to skip the oral, not always. And I decide, anytime that I take the exam, I look at the quiz, and I think, okay, this quiz is very easy. So maybe that it was just a matter of chance. How it is combined, the score of the quiz with the score of the oral. So I give a score for the quiz. So after the quiz, individually or to the whole class, if you agree, I read the marks of the quiz. You don't need to get the marks in the quiz. You don't need to reply correctly at all the questions. Usually it depends on the quiz. I take a look. Okay, this question was really tough. So I decide that, okay, it was wrong, but it was really a tough question. So, and then I give you the mark of the quiz. Typically, after I give the mark of the quiz, some students decline and say, okay, come back another time. And you can take the exam how many times you want. I don't register any negative result from the exam. So you can come 2 weeks later, it's no problem at all, okay? And the only thing that I prefer not to do is to take the oral after in another exam. If you decide to move forward, the oral is to be taken the same day, okay? And then the oral is very quick, it's like 5 minutes. So the oral, usually after the oral, the score, the mark increases. This is what happens in more than 50% of the cases. The mark increases. Like I propose for the quiz 26, and then the final result is 28. There is not a huge increase, usually, unless really something really exceptionally happens. And so the increase may be, on average, is 1, 2, 3 marks, at most 3. Sometimes it happened to me that the oral was really outstanding while the quiz was not a good thing. And then the student told me, look, I really don't feel comfortable with the quiz, but with the oral, you can ask whatever question you want. And I'm sure that I I will reply correctly. So in this case, I increased, I remember one time I increased 4 marks, but this was really an outlier. So just to give you an idea, okay? An idea that if you take 20 at the end at the quiz and your target is more than 26, I don't think it's worth taking the oral. This is sometimes it happens that I would say in 40% of the cases the mark is confirmed. So the quiz is highly reliable in my experience. It's really highly reliable. It happens in like 10% of the cases that the mark, the final mark is lower than the mark of the quiz. This may happen, so please don't assume that you cannot decrease. And this is important that you know from the beginning, because the preparation for the quiz is different from the preparation for the oral. And also, you know, the quiz allows you to consult the notes. At the oral, you cannot do that. I cannot ask a question and wait that you consult the notes and then you reply, of course. So it's a different preparation. So just be aware that it's not granted for sure that your mark is preserved or increased. It can decrease. Actually, I tell you, it happened really a limited number of times that even with a good mark in the quiz, I invited the student to come back another time. It happened really infrequently, in like, I don't know, like 0.5%, maybe less than that. Because I don't know why. This was something that you cannot explain everything in our life. So it happened that really a couple of students replied to all the questions correctly, and then at the oral, really, they couldn't say anything. So I just wanted to give you these details with the hope that you can get already from now indications on how to pass the exam with, in a nice day, okay? And then there is the question of your personal skill and background. So, and allow me to be a bit moralistic or philosophical. So it is important to pass the exam with an high mark. It is extremely important. And it is extremely important also for you, because you get stimulated, you get a boost for continuing. It doesn't make a big difference when you seek a job, unless you really have a low mark at the degree. But if you, instead of getting 110, you get 105 for finding a job, it doesn't make any difference. What makes a difference when you find a job is the interview. It's the CV, but if the CV is poor and you are at the beginning of your career, it's not a problem. Of course, if you are at my age and the CV is poor, it is a problem. But if you have an age of less than 30 and the CV is nothing, it's not a problem. But when you take your interview, this makes a big difference. And today, in these modern times, the interview is getting more and more importance. Why? Because today, if you look at the average mark of the degrees 30 years ago, and today it is increased. The reason may be that, different reasons, maybe that it's not a matter of the university became more lenient. I don't think so. I think that the things that you learn today, they are tougher than the things that I learned in my degree. I graduated in 1992. So it's not really, but it is the average is higher. So it means that one person that has to hire a person 30 years ago, if they saw a mark like higher than 98%, they were very confident that the person was good. Today, there is less confidence. Today, they know that even a person with 100% may be not a good person to hire. So they put a lot of weight in the interview. And the interview, you don't have to be afraid, because the interview is a nice opportunity. It's also very stimulating, but you have to be well prepared. And your well preparation starts today. So keep in mind that you don't have only to pass your exam. You have also to pass an interview with a good performance. And in order to do that, you have to increase your skills. So increasing the skills requires a different preparation than passing the exam. It's a different story, because you need something that remains in your head, maybe not just 1 week, maybe with less performance. So you don't need to remember fine details that you need to remember for the exam. and these fine details remain for 1 month, 1 year, you need to get a good picture of the topic. So this is why I suggest you just to keep this in mind. And this applies to all the courses and applies in particular to the courses that today are improving, are growing up. Climate change is something new. It's something that it was not in any university program up to 10 years ago. You couldn't find almost anything. And if now you look at the University of Bologna, how many courses on climate change? Maybe there is a degree program in physics. There will be a new curriculum in engineering next year, in civil engineering. But the individual subjects are really limited. So it's something that is growing up. So it's important that you get the big picture of it. It's different from structural mechanics. It's a very consolidated science with some innovation in terms of materials, but the methods for computing, they are well consolidated. It's something that requires a different study. In climate change, I give this suggestion to you: try to get the big picture. Try to understand what is the problem. Understanding means that you have to go beyond your personal opinion. You have to get a full overview, and I will give to you the opportunity to do that. I will explain to you how to do that. So there will be some things that I will suggest you study this. It's not a subject for the exam. You will not find any question on this at the exam, but I suggest that you study this. And the reason is that what I just mentioned. Okay, so just beware of your skills. And this is also why I allow you to consult notes at the exam. And I tell you, okay, you are free to do whatever you want, and beware that you are taking the responsibility for yourself. And this is what I told my son: you are cheating, that's fine, but bear in mind that it's not a problem for the teacher if you teach. If you cheat, maybe a problem for you. Okay. And I recognize that also cheating is something that can form some skills. That's fine. This is what I told to my son. I don't say that this is useless, just something that needs to be used in a good way. Okay. Okay, so now let's go back a little bit and let's start about the tutorial. One thing that I didn't tell you: usually when I teach for 3 hours, I make the break after 2 hours, meaning that I plan to start at 9:15 on Monday, make a break at 10:45 up to 11, and then 11:45. If you prefer to make breaks every hour, you just have to let me know. It doesn't change anything to me. Usually, students like this solution, but if you don't like it, just discuss among you, because of course you have to reach an agreement among you, and I can make the break every hour. On Thursday, I will start at 9:15 and will teach continuously up to 10:45 online. Okay. One more thing before I pass to the tutorial. I really like that you come in physical presence in the room, but this doesn't change anything to me with respect to your mark. I really like if you are attending in presence, and if I realize that there is a continuous need for more chairs, I will apply for a larger room. Usually this doesn't happen. After the first couple of lectures, the number of students decreases. But just beware that I'm not inviting you not to attend, because I really like on Monday, but also online, to see you. I really get, more enthusiasm if I see you in presence. But if you decide not to attend in physical presence or not to attend, it doesn't change anything. You can prepare your exam by following the tutorials and looking at the video, no problem at all. And I tell you, I could tell you several examples of students who got the laude, and I saw them for the first time the day of the exam. No problem. It doesn't make any difference for me. And the important thing is that you are well prepared. Okay, so first of all, please, in this page that I am reading, there is everything I'm saying. There is something less about the skills, about the big picture, because these are not really important details, but there is everything. So please help me to spread the voice, because it happens very frequently that students ask me, what is the exam, how it's done the exam? And every time, because I like to reply to all the emails I receive, so every time I write, please look at my webpage, there is everything, and also there is the video of the first lecture, so look at the video. And so help me to spread the voice. If it's possible, please don't send me email asking me when is the lecture, or there is everything here, okay? And the reason is that, you know, I like really to reply to all the emails, so it doesn't happen. If you don't get a reply from me in a couple of days, but wait a couple of days before sending a reminder, okay? Because there are some students who are terrible. After 10 minutes, I sent you an email, maybe you missed it. Okay, so if you don't get a reply after a couple of days, it means that something went wrong. So write again, because I really like to reply to all the emails I receive. But on the other hand, sometimes I would like to press the the delete button, because I mean, I get questions that that I've written here. I mean, there are no stupid questions. Another thing that I want to tell you, please, you have to ask me questions during the lecture. There are no stupid questions. But of course, if one asks me where I can find the supporting material, I mean, if you go on Google and write climate change adaptation, University of Bologna, and you find everything. Okay. Now, you know, I sometimes I thought that it would be nice to write a book on my experience as a teacher, but I would like to write the book in an ironic way, like a humor, with some sense of humor. And I am afraid, because, of course, students may recognize that if I'm making fun of what happened one day, they may recognize themselves. So if I survive, maybe when I get very old, maybe that I take this license of writing this book. It would be interesting, really. I think it would be a bestseller. Okay, now, these are the tutorials. So I think that we should be able to go through all of them, but it may happen that something goes wrong and some link is skipped. I will tell you, okay, because of course what I said is that for the quiz, the exam, everything is here. If I skip something, I'll tell you. Maybe that some of these pages are left to you for individual study, but I'll tell you, like this link, it's not a subject for a lecture, but please read it, okay? But I'll tell you. And if something is definitely skipped, I will remove the link, okay? Now, how these links are done, so let me open, there are some differences, but usually the links are in the form of web pages. Just give time to open, like this one. It's a web page. And why a web page instead of a PDF, for instance? Because I like to make revisions. This is evolving material. And it's much easier for me to change, to edit a web page. For instance, I found today a couple of errors in the previous page with respect to this one that I'm displaying now. And it is very easy for me to change. To change a PDF, I need to go back to the Word file and print it and upload on the web. It's a bit of a problem. And also here, as you can see, I can include links, several links. And of course, I could include also the links on the PDF, but it's a bit more complicated. So this is why web pages. If you like the PDF, it is very easy. You make just the right and print. Okay, no, the right no, but anyway, you can print it. It's very easy. You may be afraid, for instance, because you have a poor connection, because of course you need a connection in order to read these web pages. You can save the web page offline, or you can print it. It's not a problem. At the end of the web page, very often you will find a PowerPoint. Let's see if there is here the PowerPoint. Yes, download the PowerPoint presentation. Look, I don't suggest you to use the PowerPoint to study. It is just for me to teach, because I cannot teach with this. You know, I cannot display this. I mean, I could, but sometimes I do, but it's not very convenient for you to read so much text. But the implication is that the PowerPoint has less information. So please, what I said, everything that, any question that you can find in the quiz is taken from these web pages, but not from the PowerPoint. Be aware of that. If you only study on the PowerPoint, you don't get, of course, you get a reduced information. The PowerPoint may be good for you if you just want to refresh, like the day of the exam or the day before. You may like to refresh. The PowerPoint may be good, but don't use it just for studying, okay? And another thing, when I modify a web page, I put the date here. So if you print it, if you study it offline, just make sure that you have the updated version, okay? Now, what about the links? There are usually several links, like for instance here, feedback. What is a feedback? You don't know what is, you click here, and 99% of the time you will be redirected to a Wikipedia page. So these links, you don't need to follow them in order to take your exam and to be successful at the exam. The links are only to be followed if you don't know what is the meaning of the linked word, or if you feel that you are interested, like you may find a link to the Bayonne disaster. So if you want to learn more about the Bayonne disaster, even if it's not a subject for your exam, you click there and you get to the information. Once again, the links for the exams are not needed. You don't need to follow them. You have to follow them only if you are particularly interested, if you want to get a larger picture. It's up to you, and it's just an aid. As I said, everything here is open access, so you can reuse everything. If you cite the source, if you make a reference to the source, I appreciate it, but actually you don't need that. Okay, so if you want, of course, you have to be always careful when you make a cut and paste from the web for the legal implications, and in this case you don't have any legal implication, but also for the accusation of plagiarism, which is unethical and sometimes has a legal implication. So you cannot make a thesis by cutting and pasting from Wikipedia, even if Wikipedia is open access, because this is not legal. There are some creations that have to be the result of your own work. You cannot make plagiarism. So it depends what is the reason why you make cut and paste, okay? But usually when you make cut and paste, you have to quote. On the other hand, I mean, if you want to use the figures, you put in your thesis source albertomontanari.it and you are done. You clearly recognize that it's not your own product, but you believe it is useful, you can do that. Beware of plagiarism, because it is a real risk. Nowadays, it is very easy to get you if you cut and paste or you write something with ChatGPT or etc. It is very easy, and the implications are very. I mean, I can give you a couple of examples. A colleague of another university took a picture on the web for making the flyer of the degree program. He was the coordinator. He was fined 3,000 euros on his personal pocket because the author of the picture recognized him and said, okay, sued him, and he had to pay. And the university doesn't pay for that. So beware that the risk is real. Another university, a student used a software and hacked the software from the United States. So he was quite firmly convinced that nobody would get him. And at the end of the story, the results were published somewhere, and the The software house recognized that these results could be obtained only with that software, sued him, and the requested fine was 30,000 euros. At the end of the story, he managed to reach a compromise. I don't know how much he paid. He was a student, okay? He was a student of another university. Third example, a couple of students from the University of Bologna took an agreement some years ago, and they used the same thesis at a distance, okay? And both of them, the degrees were rejected, declined, withdrawn, and they were disallowed to subscribe for a lifetime at the University of Bologna again. And they shared the thesis. Okay, of course, these are some examples that are like, but what I want to tell you is today you deliver your thesis in digital form. It is full of softwares, anti-plagiarism. It's very easy to, okay, and in scientific production, there is an indication that is given to scientific editors. They run anti-plagiarism, and if the number of matching text in percentage is larger than 15%, they give advice to the editors to look carefully at the content. So this is an order of magnitude that I give to you. And they get the same sentences, and they say, okay, let's take a threshold of 15%. Why 15? Because some of the sentences may be the same just by chance. So they don't say like 2%. They recognize that if it is 15, indeed, there is something statistically proved that was on purpose cut and pasted. Be careful of that, because really it's not a nice experience. Okay, so these are my tutorials, and we will go through them in sequential order. Okay, today we will start with the introduction after the break. I think here, okay, exercises, I forgot. We will dedicate like 8 hours to solve exercises with very simple applications on the PC with a programming language. I try to avoid Excel, but I would like to make some experience with you to write codes, because I think it is still very important. You know, when the digital revolution started, more or less when I took my degree 30 years ago, when the digital revolution started, it was necessary to write codes because nothing was already prepared. Today, basically, you can find on the web almost everything that you need. So it's less needed to write codes, but still I think it is an important skill. And it is even more important because less students are able to code today, at least in these degree programs. Of course, if you go in informatics, they can code. But I really would like that we make an experience together. I will use R as a software. I will explain to you why R and what is R. It's similar to MATLAB. So if you have experiences in MATLAB, you are already fine with this. And I'm not sure how many exercises we will be able to make together. I will tell you earlier, typically the online lectures will be dedicated to problem solving and to coding because it's much easier for you. And if it's not online, I don't think it will happen, but if it's not online, I will ask you to bring your PC or your tablet in the room, okay? Because I cannot book a lab. It's almost impossible for so many people. But typically it will be online. Okay, good. A few words on, to get to the break, on interactive learning. I am a fan of interactive learning, but I realize it's a bit of a challenge because students usually, at the beginning, you don't like typically to interact with the teacher. But I really would like to make you a couple of examples on how we could interact. And the first bullet point is extremely interesting. Short presentations by students. Last year it was very successful. After the first student volunteered, then I had to make a calendar because several students wanted to present. Okay, what are short presentations? they are technical presentations. Technical means that you don't have to present your view, your philosophical view on a subject, but there should be a presentation with some technical content, not necessarily complex content, but some technical, like, for instance, a case study of how climate change adaptation was resolved in a particular country or a particular city, with some technical details, like if it was a water reservoir, the size of the reservoir, how it was designed, etc. The presentation is short, like 5 slides, 5, 6, and with a total duration of no more than 5-8 minutes. And then we open a question and answer session. I think this is useful because it trains you to deliver presentations and to speak in front of an audience, which is not, it's something interesting, okay? There are some people that don't have any problem, other students that feel more embarrassed. And so I think it is good. The presentation should be relevant to climate change adaptation, but different from what I'm teaching, of course. You don't have to substitute me. You have to complete the picture, give examples. This is what I invite you to do. Typically, let's wait a couple of weeks before starting, and maybe also more than 2, maybe, let's start from the mid of the course, but you may also volunteer in a couple of weeks from now if you feel that you have a good subject to present. A typical question that comes from students is, can we group in more than 1 people to deliver the presentation? My preference is for individual presentations because it's more useful for you. But last year, given that I had many requests, I allowed to up to 3 persons presenting. You understand that 3, with a total duration of 5-8 minutes, you need to be very efficient. So I'm not sure whether it is really a good solution. And you have to train to stay in your time. So if you are planned to speak for 5-8 minutes, you have to speak for 5-8 minutes, not for 15, because otherwise, when you get an interview, they tell you, or they may not say anything to you, but usually you have a duration, total duration, and they appreciate that you can deliver concepts in an efficient way. So don't speak too much when you go to an interview. Of course, you don't have to be very short, but don't speak too much. This is the first suggestion that I give. Okay, so, but if you are a couple of students, that's fine, okay? Just keep in mind that these short presentations don't give you any credit for the exam. It's just something, of course, there is no need that I add anything. If you deliver a presentation, it is something that impresses everybody, including the teacher. And even if the presentation is not outstanding, it is something that may be useful, but there is no formal credit, okay? But I find that it's very interesting. So this is a first opportunity. Second opportunity, when we go to coding here, if you volunteer to translate the codes that I will present you in R into Python, this is something that I started last year. This is something that is really appreciated by me. I don't know Python. I am learning because I realized that Python is, I was saying the future. Not sure, maybe that the future is ChatGPT, but indeed, MATLAB are already part of the past. Python gives you more opportunities. What is the advantage of coding is that you do something that is really advanced, something that the others don't do. And for instance, figures. With R, MATLAB, you make outstanding figures. Python probably is even better. I have a PhD student who presented a figure a couple of days ago, and they said, how did you do that? Because it's amazing. And he said Python. Okay. And they said, why didn't you do it in MATLAB R? Because Python was a little bit better. So if you translate the code in Python, this is much appreciated. And maybe that you can also deliver a short presentation on how I did it. So Python requires start from the basis and just a very short. And in this case, I can also allow you to present for more than 5-8 minutes. This is much appreciated. If you expand into Python, much appreciated. Again, no formal credits for the exam, but when I say much appreciated, you understand. Okay. Okay, now I will also deliver to you an anonymous questionnaire after after a couple of weeks. It's already available on Virtuale, but don't fill it now. Okay, in a couple of weeks, I will invite you to fill the questionnaire. Why? Because you know that we have a survey at the end of the course, close to the closure of the course. But the end is the end. So I mean, I really like getting your feedback. And if you have any suggestion to give to me, anything, spelling errors in the lectures or something that you think that should be written better, don't be afraid. I really like to be challenged, and I really like your criticism. And frankly speaking, I really appreciate that. So if you have any suggestion for interaction, for something that you would like to discuss, provided I agree, of course, and to integrate, to write a new web page on a new tutorial on something that we could expand into. I really like getting your feedback. Okay, there was one more thing that I wanted to ask. I don't remember anymore. Okay. Contacts. My email is very easy, alberto.montanari@unibo.it. If you need any clarification, send an email. And if you also want to get individual clarifications or group clarifications for lecture, usually I don't get many requests because usually everything is written there and everything is relatively easy. You will not find this course complicated, complex, or mathematically heavy. There is some math, but it's not heavy. So usually I don't get many clarification for request and any request for clarification, but I don't have any problem. So via Teams is very easy. So if there is something that you want to discuss with me, maybe better if you group in more than one student, but even individually, just write to me, and that's fine. Something that is not written here, thesis. Yes and no, meaning that I am. The topic is very hot, so I get many requests for thesis on climate change. Maybe, but not many. So, but I have several colleagues who are not teaching on climate change, but are very expert. So, if you would like to make the thesis on these topics, and you feel that I may be the advisor that you may like, no problem. Just send me an email and we can discuss. You are the first year, so it's a bit early for you. On the other hand, please don't assume that I am available because it's a bit of I need to really juggle with many things. And I am very motivated in teaching, dedicate time to teaching. So I usually attend some students, but not many. Okay. I think I did. I went through everything I needed. One last thing I want to ask you, another pool, which is quite important. Some of you are attending also the other course I'm teaching, Science of Climate Change and Climate Action. So raise your hand. Nobody. This is great. Very good. This is great. Okay. This is an optional, and it's a soft skill course. Next year, it will be no more a soft skill, because next year you may know that soft skill courses are not more delivered by the university, or they are delivered but without credits. So we transformed this other course in Science of Climate Change in an optional for engineering, but it can be taken by everybody in the uni. and it's 3 credits now. From the next year, it will be 6 credits. I'm delivering to you this information because if you're interested in climate change, it could be an optional interesting for you. And it will be 6 credits, so 48 hours. There is some overlap with climate change adaptation, but it's quite limited. In terms of hours, I would say maybe 6 hours of overlap. It's very limited. We need some overlap because the students are not the same. They are different groups of students, and this is why there is some overlap. And I am teaching it now. Next year, I think I will teach half of it, and the other half will be taught by a foreign professor who is very expert about climate change, and he is will take a job at the University of Bologna from the next year. He will take a job. Okay. I think what we can do now is to take 15 minutes break, and the next hour we will start with our introduction. Any questions so far? Good. Okay. Okay. Okay, we can start with the first link, introduction. Let me put it to full screen. Okay, this is a kind of interactive web page, and it's different from the usual web pages. This is interactive. Anyway, you can play it from the website as you want. It already includes some potential questions for the quiz. I just wanted to tell you it's different from the other web pages, but as you will see, there are slides, so it's like a PowerPoint. It already includes some information with some potential questions. So this is, first of all, an introduction to clarify what is climate change and what are we talking about, okay? So these graphs are taken from our website, which is called Our World in Data. First, let's have a look at the link, because I think the website is extremely interesting. Our World in Data gives public data about many things. So this is, for instance, global warming. It's a graph of global warming starting from, you can start usually from whatever you want, these graphs. Like, let me see, settings. No, this is not, okay, but in settings you can split by region, and I'm not sure if it's available, this for temperature data, but in general, Our World in Data gives to you the opportunity to see the global data or for each individual country. And then I will show you what other kind of data you may find. I think this is useful information for you because really they have a lot of things here. And this is a graph, let me see if it is possible to go back in time, because this is, no, it's starting from 1880, sorry. So it's fine. This is the progress of global warming, and you can see also it is updated. What you find in my website here, it's not up to the end of 2023. Just one second. It's here. My graph is here, and you see that it's up to 2022. Of course, clicking on the link of the website, there is an update. And this is global temperature, and the zero is, I think the zero is set at the average. At the average, so this is anomaly with respect to the average. It's a graph of anomaly with respect to the average, not really a graph of the temperature. And what you can see from this graph is that if you start from 1880, the global temperature is increased about 1.2, 1.3. Okay. Of course, it depends on whether you look at the extremes, like here, for instance, if you take an average, if you look at the last data, 2023, as we will see, has been the hottest year on record. And you can recognize it up there. There is a spike. And previously the record was set by, I think, 2016. Not I think, it was 2016. Maybe it is this one, because this is monthly data. But if you average over the year, as I said, 2023 has been the hottest and 2016 the second. So it depends on whether you compute the average on this full window. So you get to about 0.9 maybe here, but then you have to add, starting from here, here we are at minus 0.3 more or less, if the average is here. Of course, it depends on the length of the window where you compute the average. And it's about plus 1.3. This is the first information that you have to learn. So when we talk about global warming, meaning global temperature, the range of the global warming from 1880, 1850, is plus 1.3. This is extremely important, okay? There are hotspots over the globe. So there are regions where the temperature is increased more. One hotspot is the Alps. The Alps, the temperature has increased about 2 degrees. In general, the northern hemisphere warmed up more than the southern hemisphere. And there is a difference of about 0.3, 0.4. You can check. And just for you to know what is the order of magnitude. First bullet point. You are studying something related to engineering, or you are engineers. Orders of magnitude are extremely important. So when you talk about a phenomenon, it's extremely important. So if you don't have clear in your mind what is the amount of global warming, it's a problem. And then you talk with people about global warming. So you have to get clear that we are not talking of plus 10 or plus 0.1. We are talking about plus 1.3. Order of magnitude means a factor of the order of 10. But what I want to mean is that if you say plus 1, or if you say plus 1.5, is not a problem. If the correct information is plus 1.3, being aware of the order of magnitude means that you can tolerate some range of uncertainty. So it's not a problem if you say plus 1. It's a problem if you say plus 0.1, or if you say plus 10, or plus 5. It means that you don't have a clear idea of what you're talking about. Orders of magnitude are extremely important when you go for an interview, because this is typical, that the people want to know if you have a perception of what you are talking about. So in this case, I think that almost all of you knew that we are talking about plus 1 something. But there are orders of magnitude that are less obvious, like what is the average amount of rainfall that falls in Bologna in 1 year? Or what is the average amount of rainfall that falls over the globe in 1 year? This is less obvious. But if you are talking about climate, you have to know this information. I mean, it's not a problem. So the average rainfall in Bologna is 800 millimeters, 0.8 meters. It's not a problem if you say 0.7 or if you say 1 meter. But if you say, I don't have any clue, it's a problem. If you talk about climate, you have to know what are the main order of magnitude of climate. Okay, so this is a chart of global warming that clarifies what is the problem. Don't think that plus 1 is not significant, is a lot. In terms of energy, means a lot. On the other hand, don't assume that the number alone says everything. You can see another important feature on this graph, variability. Okay, so here it goes down. I'm sorry for those who are attending online. I need to share the screen. Be patient because I am at the beginning and I forget some important things. Just 1 second because. Okay, share. Okay, share here. Okay, good. I'm sorry for that. So, if you look at a small window, you see that the tendencies are changing. Here it's decreasing, here is increasing, here it's decreasing, here is increasing, here there is a kind of stability, and then there is a jump, another kind of stability, and who knows, maybe that 2023, 2024, who knows, okay? So variability is important. We'll discuss about variability. And don't assume that this is unprecedented. In the past, the temperature over the Earth was really more than that, much more than that. And we are in the tail of a glaciation, so we have ice at the poles, but for the history of Earth, there were long periods without ice at the poles. So in the past, we had, even without humans, periods that were hotter. Okay. On the other hand, I mean, this is clear. And what is interesting, but before I go to the next graph, let me just show you some few things again on our world in data. You see here by country, Data Explorer, CO2 emissions, CO2 by fuel, greenhouse gases emission, etc., climate impacts. So let's Data Explorer. Let's have a look. And okay, this is per capita CO2 emissions for several countries, and you can play here. You can look at Italy, etc. And by sector. No, it's not, sorry. Let me browse by topic. This is what I wanted to. So this is, these are the categories of data that you can find here. Population and demographic change, health, so health, causes of death, energy and environment, food and agriculture, poverty and economic development, education and knowledge, innovation and technological change, living conditions, human rights and democracy. This is extremely interesting. Not for now, not for us in this subject, but it's extremely interesting. Violence and war. So there are a lot of data that you can find on this website. Okay, now let's look at the other graph, global freshwater use over the long run. And this is global. And okay, in this case, the order of magnitude is not really what is important, but it's important to see the trend, starting from 1901 up to 2014. I mean, you can find several similar graphs which prove one thing that I think it's interesting to associate the graph of global warming on the left. Proves that after the Second World War, so about 8 years ago, we had an increase of several standards, living standards, water demands, several other standards, which motivated people to introduce the term great acceleration. What is the great acceleration? It's the increasing trend in various measures of human activity that occurred after 1945. And of course, this is a good thing. The fact that we are using more water, it's a good thing, because it means water is associated to living standards. It means that more people are using water. It means that, the welfare is increased. This is also associated to the increase in human population. And you know that we increased from 1 century ago from about, there is also the number in our world in data. Let me see, so we are precise on that. And just 1 second, topic, population and demographic change, population growth. Let me see, where is the graph? Data Explorer. Okay, here it is, but let me take the global world here, and let's take away the countries. Let's look just at the global. Okay, so let me just see if we can. Okay, from 1950, 2.5 million, and now we are at about 7, close to 8 billions. And this is also a good sign, because it means that, I mean, the increasing population means that indeed we are promoting a better standard for living, because we couldn't increase the population without a peaceful period, at least in a part of the world, in a large part of the world, and without also increasing the welfare. Of course, there are more things that we could say about that, because unfortunately, this population increased, but a large part of it is living in conditions of poverty. And again, you can see data here about this. But the important thing is to notice that there has been an increase in several indicators of exploitation by humans of natural resources. And this is associated to an increase in temperature. So it may be a coincidence, but of course you understand that the fact that we are using more resources, we are using more fossil fuels, we increase the living standards, and then the temperature is increasing, suggests, of course, an association between, for sure a correlation, but also an associations between these variables, which it's a clear indication. Great acceleration, there is a link to a Wikipedia page which explains what is, and here you see population, GDP, gross domestic product, and urban population, energy use, fertilizer consumption, and transportation, telecommunication, all of these, and also Earth system trends, carbon dioxide, methane, stratospheric ozone, surface temperature, or ocean acidification. So we are talking about this. So about this great acceleration. Okay. Now, what is climate change then? Sorry, it's not full screen. Okay. What is climate change? Okay. This is interesting. So I would like to also to make a pool with you. I could also use some automatic, but let's try to raise hands. So here there are 4 definitions, and let me see, because for some reason it doesn't. Okay, 4 definitions. Only one is correct. So who is voting for the first? Okay, no abstentions are allowed. Okay, it's fine. Second, who is voting for the second? Who is voting for the third? Who is voting for the fourth? I start again. Who is voting for the first? Much better. Okay. Who is voting for the second? Third? And fourth? Okay. The right answer is the first, and I think that there has been a kind of mutual influence, because of the first round I didn't see many raised hands. So climate change is a long-term shift in weather patterns. What is weather and what is climate at this point? And this is first of all, climate change. Let's click here. Okay, good. It says that we are right. You can repeat this how many times you want independently. Now, what is weather, what is climate? And this is the subject of the second game. So basically, we have to put words here, and the words are somewhere. Okay, you have to place, okay, it's explained here. You have to place climate, one occurrence, and weather, 2 occurrences. Use the capital for the first letter of each paragraph. Okay, so there is a white space, and then refers to the day-to-day state of the atmosphere, such as the combination of temperature, humidity, rainfall, wind, and other factors. Second space, blank space, describes the other missing word of a place averaged over a period of time. Okay, so we have three blank spaces, and we have to place climate once and weather twice. Okay, so the first blank space, should we put there climate or weather? Weather. Okay, good. Weather. Day-to-day state. Okay, let's put climate here and weather here. Okay, so weather is day-to-day. Climate is average. Okay, so the average of the weather is climate. Weather is day-to-day. So some reflection. It's a mistake to say today is too hot. This is a sign of climate change. No, it's not a sign of climate change. If the graph that I saw before is a sign of climate change, global warming, because if I take the average over a long period of time, indeed I see an increase. But the fact that today is hot, tomorrow may be very cold, so the average is just in between. So let's make the difference, because it's typical for the media after a hot week to say, climate change. And this is a mistake. And it's misleading, because, it's not a hot week that makes a climate change, but it's an average over a long period. How long? In climate science, people say 30 years is the window over which we should average. This is subjective. Some people say 10 years, some people say 5, some people say 50. And it makes a difference, because if you average over increasing lengths, the change is get smoothed, While if you say 2023 has been the hottest year on record, I mean, this is astonishing, and it's something that gets the attention of people, something striking. But if you look at the previous graph, indeed, if you look at the last part, and okay, here you don't see 2023, but in the last part, you see that there is a kind of, it seems, stability, okay? And the same kind of stability you can see here. This is called the hiatus. Global warming started around 1980, and then there has been a sharp increase in the 90s, a hiatus, kind of stability for 10 years, to 2004, 2014. A lot of controversies, because several people said, okay, it's over, now it starts to go down. And then we got almost 10 years, no, let's say 5 years of sharp increase. And then we have 5 years of stability. But 5 years are not significant. 1 year is not significant. You cannot say climate is stabilized in the last 5 years. No, absolutely not. You should look at 30 years, and then you say global temperature is increasing. Again, it's extremely important that we know what we are talking about. The definition, what is weather, what is climate, it seems that you had it clear already. It's extremely important. Let's be able to make the difference, okay? Because unfortunately, the topic is treated by the media. The media look for getting the attention of people, for striking news. So the topic as treated by the media, it's treated in a way that is not really leading to the correct definition, to the correct perception of the problem, okay? It's important that we are indeed persons with a background, with a scientific background, so we have to be able to make the difference. There is a lot of topic, a lot of discussion on communication of climate change. So some people think that it's important to be striking in communication, so to predict disasters. Other people think that it's a duty of scientists to communicate the truth, not the convenient truth. It's an interesting discussion. We don't talk about communication, okay? But one thing is communication. So I agree with communication. If you want to get the interest of people, you have also to look at the extremes, at the weather. Because actually, I mean, when we talk about floods or droughts, this is weather, okay? So it may be important to talk about weather. On the other hand, it is extremely important that we have a scientific background. We have to be rigorous. Let me introduce another couple of definitions which are extremely important. Variability and change. And this is already a definition. I think you know already the difference because your background is a scientific background. The media often don't really clarify what is the difference. And the example is the graph, the animated graph on the left. Temperature change from 1850 to today of Northern America and Southern America and tropical America. And you see that there is an increase in both cases. Of course, there is global warming, but the shape is very different. In Northern America, there is more variability, and in tropical America, less variability. When there is a lot of variability, we are more in trouble, because it's more difficult to predict what's going to happen in the future. You know, so variability is a measure of spread. Change is a long-term shift. It's a different story, but in the short term, change may be confused with variability. So let me go back to, again, the graph of global temperature. If you take this graph on the left, I mean, what is variability? What is change here? If I take only the first part, I would say, oh, here there is cooling. If I look at the period between 1930 and 1970, there is cooling here. And indeed, if you look in Wikipedia, global cooling, you find the link in my web pages. Indeed, around 1970, there were widespread concerns about global cooling because people were concerned that the temperature of Earth was going down. And indeed, now we can say it was the result of variability. But had we had only this data, we wouldn't be able to say that. And in this case, imagine that we can look in the future for 200 years. What it would be maybe that we could conclude, maybe that in 200 years they will conclude it was also this trend, an expression of variability. And if we could go back into the past, like 2,000 years, we would find that around 1200 there was what is called the medieval warmer period. The temperature was as high as today. Okay, so distinguishing between change and variability, it's not easy. It's important that we have clear the difference. Variability is expression of spread up and down. Change is a long-term shift. Unfortunately, in order to distinguish, we need long records, and we don't have long records. Why these graphs start from 1850? Because this is the start of the so-called instrumental period. Temperature is measured at the global level starting from 1850. Before then 1850, we have infrequent measurement, sporadic measurements here and there, but we cannot compute a global temperature. And also keep in mind that during the instrumental period, where we have observations, the density of thermometers is increased a lot. So the time series is not homogeneous. Homogeneous means that the measurement technique is unchanged during the period. Here, they changed a lot. And if you look, for instance, at temperature taken by satellites, which is different from temperature measured over the ground, these graphs are ground temperature. satellites depict a different trend, depict an increasing trend, but different. What is the reason why we don't have measurements going back to the far past? This is an interesting question. Because temperature, okay, it's a bit sophisticated, but if you think of rainfall, rainfall is very easy to measure. You just put a tank outside, every day you go there and measure, very easy, but people didn't get this idea before. Why? Because, I mean, people started observing the stars, astronomy in very far past. Why they didn't measure climate? Probably because they don't needed it. Probably. I mean, they needed to understand astronomy because they had to get oriented when navigating in the sea, okay? And therefore, it was a clear need. Probably they didn't have the need to measure rainfall. For instance, the Egyptians measured for 600 years the annual level of the Nile River. And it was very easy. They had a staff. And then every year they went there and saw the sign of the mud over the staff. And they went on for 600 years because they needed it. They needed it because you know why? Because the Egyptians relied on the floods of the Nile River to fertilize the land. And so probably people didn't need to measure rainfall. And I tell you one more interesting thing. People understood only about 500 years ago that floods were caused by rainfall. Before than that, they thought that they didn't know. And they thought that it may be water that comes from the underground. Why? Because they didn't have communication. So sometimes they were flooded without any rain. Think of the Po River. You can get Ferrara flooded without any rain because it rains over the Alps. Or it may be something related to snowmelt. So no rain, sun, and a sudden snowmelt, and people got flooded. So, I mean, the water cycle is something that people understood only recently. 500 years ago is nothing. I mean, with respect to the span of the human life, it seems a lot. But if you think the time span of natural processes, climate, is 500 years is nothing. Okay, even 1,000 years is and 200 years from 1850 is really nothing. So unfortunately, we know very little about climate, unfortunately. So if we have to make a prediction, it's a problem. Okay, now, another interesting question. Why do you think that humans are responsible for climate change? So, I mean, it's one of the major concerns of modern society. I already mentioned to you that the attribution is a relevant question. We don't talk about attribution, but I think it is interesting to ask this question. And I am asking this question because 1 year ago, oh, it was 2 years ago, I don't remember. Yeah, it was 2 years ago. It was in 2022. I attended a summer school. I was teaching at a summer school with a famous climatologist. He's a famous colleague. He's a climate scientist, and he asked this question. And I was very surprised because he is firmly convinced that humans are responsible for climate change. So I was surprised that he asked this question. And I think it is he didn't propose a closed answer question. He just asked it, and he had less students, like 15 students. So I prefer, in this case, to go with the closed answer. So who is voting for the first? Who is voting for the second? Who is voting for the third? Okay, fourth? Okay, let's start again. First? Okay. Second? Okay. Third? Okay. Fourth? Okay, the majority is for the fourth, that actually is the correct answer. Okay, so it's not true that, let me see if I can go back. It's not true that, okay, good. It's not true that, okay, it was shuffled. It's not true that it is occurring with unprecedented speed. We had, of course, when we talk of the far past, I will tell you how we reconstruct the data that were not measured. But we have clear signs that there were periods when the temperature changed very quickly, at least after volcanic eruptions, but not only after volcanic eruptions. It's not true that the reason is that the scientific community agrees. This is very controversial. It's true that the majority of the scientific community thinks that anthropogenic forcing is dominant, but on the other hand, it's not the explanation. And of course, the media are not an explanation. The explanation is that climate models cannot explain current climate change unless anthropogenic forcing is considered. So it's models that tell us that humans are responsible for climate change. And this is an extremely, I think, interesting conclusion. At least for an engineer is interesting because you know that scientists believe in models. Engineers, there is a say, engineers believe in data. And of course, I don't agree with this say, but it is, I think it is very significant because it makes, again, the difference between science and engineering. Engineering is also science, but has an applied part. So now we are talking of the application, of the applied part, of the technological part of engineering. The technological part of engineering is supposed to rely on evidence, not models. Of course, we use models in engineering for making predictions, but we have rigorous standards for model validation, meaning verification. And if the engineer takes a responsibility, the most obvious thing to prove that a choice was made on reasonable grounds is to show data, not to show a model result. So if you are sued because you made a mistake and you say the model said this, you don't get out of it. If you say, look at this data, I used this data and I analyzed the data in this way, it's considered to be much more solid as an explanation. And indeed, on the other hand, scientists tend to say that data are uncertain while they trust models more. It's interesting. It's interesting because we are talking of an issue that is extremely important. It's not something, philosophical. Because you understand why. Because if there is uncertainty on that, it means that even if we mitigate climate change, nothing could happen. So when you talk about adaptation, mitigation, it's important. And let's try to be very objective. So I think an engineer has to be very objective. And this is what I'm trying to vehiculate to you. I'm not telling you what I'm convinced of. It's a different story, okay? It's a different story, my personal opinion, and to try to give an objective perspective. If you see something wrong here, just let me know. If you think that I'm not objective enough, just let me know, okay? Okay, good. Now, let's move forward. Some numbers. The numbers are really impressive and are very concerning. So, increase of global temperature. As I said, plus 1.3 is a lot. If you look at the extension of glaciers, which means water resources availability, where water resources are originated by snowmelt, this is a big change. The extension of glaciers has changed a lot. This means fresh water, okay? Temperature increased more in the northern hemisphere. We already talked about it. There are some doubts on the reasons of that, but just think that in the southern hemisphere, we have less thermometers because there are oceans, and also different climate because there are oceans. Sea level rise from 1880 to 2020 is about 21 centimeters of global average. Please memorize this order of magnitude. When you listen to the media and they say something like plus 10 meters, it's absolutely unreasonable. Sea level rise is 21 centimeters, which is not synchronized with the increase of temperature. It is along the whole extension of the instrumental period. Of course, sea level rise reacts to an increase of temperature with some delay, so you shouldn't compare them. But what is important to consider is that sometimes we listen from the media about highlands that are going to be submerged. There is no evidence up to now that we are losing islands due to sea level rise or coastal areas due to sea level rise. In order to lose areas, we need to admit that we get a sea level rise of an additional at least 1 meter. So if you sum up another 1 meter, then it happens that you may lose a significant extension of coastal areas. But we have no signs, no clear signs up to now of the likelihood of such an event, unless something unexpected happens, like a sudden melt of the ice cap. It may happen. We don't know in the past history of the Earth how long it took the ice cap to melt. It may be sudden because sometimes we get outbursts, which means that inside the ice cap there are reservoirs of liquid water, very huge. And this is a recent discovery, and people are still making research on that. It is encapsulated because with the high pressure of the ice over it, the water remains liquid. And these are huge. So sometimes we know that outbursts, sudden floods happen. So sudden releases of these lakes, hidden lakes. So it may happen that, we don't know that, maybe that there is some very large lake that is going to explode in a moment. And this may cause a sudden sea level rise, but we don't have any indication of the likelihood of such events. We can just assume that it may happen, but we don't have any certainty about it. Global CO2 emissions have raised from about 5 to about 35 billions of metric tons from 1940 to 2020. This is a typical example of a question at the quiz where students were confused and made several mistakes. Keep in mind, a closed answer means that the alternatives are more different. Okay, but students didn't get this. Okay, more different, I mean that the other alternatives, there is an alternative, the range is 535, and the alternatives are like 0.1, 0.5, or 500, 5,000. Okay, this is just to give you an example of something. This is important, you have to know this. If you are talking about climate change, the order of magnitude of the CO2 emissions must be known to you. From 1940 to 2020. Per capita, 2 tons in 1940 to about 4.5 tons in 2020, more than twice per capita. CO2 concentration, 25, increased 25% from 1980 to 2020. Global economic losses from weather catastrophes are about 300 billions of US dollars, steadily increasing. And 2023, hottest year on record. On the left, global population, 2.5 billions in 1950, 8 billions today. Okay. I closed the lecture today with this video from NASA, and it was published like 20 days ago. Sorry for the okay, salta. Okay, this is a video of the increase of temperature. This is the date in summer. in summer from 19, I think is from 1900 to today. And you see where are the hotspots, but you see also a large variability. Of course, the figure is getting redder and redder, but there is variability in the hotspots. Okay, good. Okay, we will see again each other on just 1 second that before you leave, just 1 second, sorry. I need to close the... Okay. Give me 1 second, I close the registration. Okay.